right, the topic of monopoly. So this is going to be the first half. We will not finish monopoly in this lecture, so it will continue next class period. But we've already introduced the idea of monopoly. So remember that this is one of our 4 market structures, and it's the one that falls on the very far right side. So if this is perfect competition, then monopoly falls all the way at the other extreme. And I want to remind you of what changes as we move along the spectrum. So remember, as we move in this direction, what are we gaining? What do we have none of in perfect competition? Market power. Great. Market power. So we gain market power. So monopoly is going to be our market structure where firms have the most market power, whereas under perfect competition, that's our structure where firms have the least amount of market power. And we've introduced the assumptions, but let's start there just so our notes are complete. Let's remind ourselves of the assumptions of monopoly. And remember, those assumptions are going to generate conclusions. So we need to be able to make the links between the assumptions of the model and then the conclusions. So the first assumption, remember, we're assuming that we have a market comprised of just one firm. So we have a market comprised of just one firm. So if we have a market comprised of just one firm, then we need to understand that the market and the firm are basically the same thing, right? When we talk about the industry, I'm talking about the firm. And when I talk about the firm, I'm really talking about kind of the whole industry. So the market is comprised of just one firm. So guys, how many graphs then am I going to need to draw for monopoly? Yeah, only one graph. Good. Whereas under perfect competition, since under perfect competition, one firm was just a teeny little part of the whole, we needed the 2 graphs. We needed the market and we needed the firm, but here we only need one graph. Okay. So we want to be very clear that this one firm is the sole producer. So right away, we can see that our graphical depiction of monopoly is going to look very different than perfect competition, where we needed 2 graphs. All right, so market comprised of one firm. Our second assumption is that we have a situation where there are no close substitutes. No close substitutes. No close substitutes. So we're in a situation with no close substitutes. Now, does that mean there are no substitutes at all? No. Be very clear on what we're saying here. We're not saying there are no substitutes at all, but we're saying there are no close substitutes, right? Think about it. If there are close substitutes, can I really remain a monopolist? No. So I can't have close substitutes and remain a monopolist. So we understand the role of that assumption, no close substitutes. Because if there really are a lot of close substitutes, then I'm not going to be a monopolist. Our third assumption is that we have barriers to entry. Barriers to entry exist. So we have barriers to entry. And sometimes you might see this called perfect barriers, or you might see it referred to as high barriers. But there are barriers to entry that exist. So make sure you remember what happens when we have barriers to entry. It changes the ease of entry. In this case, if we have perfect barriers or high barriers, it's going to be very difficult. Or it could even be impossible. So barriers to entry exist. So we're talking about 3 assumptions for monopoly. Market's comprised of 1 firm. The firm is a market. The market is a firm. 2, there are no close substitutes. And 3, there are barriers to entry that keep out the competition. We might say that those barriers are high. They might be even perfect barriers to entry, but it makes it very difficult, or in some cases impossible, for you to enter. So let's talk about some of the barriers to entry that we see. So we've already talked about some types of barriers. Remember, we talked about in the soft drink market, entering to compete with Coke and Pepsi would be so difficult because of brand name, because of size of the industry. So some others that we want to add to the list, there could be some legal barriers to entry. So something that would create a legal barrier to entry might be something like a patent or a license. But let's look at the example of a patent. So we see patents on things like, for example, medicine. So if you have a patent on a medicine, can anybody copy your medicine? No, and that patent's going to last for a certain number of years. I don't remember how many years it is, but for a certain number of years, you have the exclusive right to produce that medicine. Now, after your patent expires, then you might see competition, right? Then you might see generic brands come, and then the whole pricing structure might change. But if you are a firm and you invent a drug, you have a patent. So if there's a patent in place, can I enter the market if I'm also a pharmaceutical company and produce that drug? No. So it would be impossible, right? So this would be an example where it would be maybe not just a high barrier to entry, but a perfect barrier to entry, right? Because there's nothing I can do to enter a market and produce the same drug if somebody's got a patent on it. So legal barriers do exist. Another example of a barrier to entry might be an exclusive franchise. An exclusive franchise has been granted. Now, we don't really see a whole lot of this, but we do have one very good example where government has given an exclusive franchise to be the only producer. Any idea who it is? What was it? The Mint? That's a good guess. What was it? ABC stores? No. Although in Virginia, I couldn't understand why it all said ABC stores for everyone, because I'm from Texas and we don't have government provision. But I'm thinking about something national where you're not allowed to compete with them. Something that you might use every day. What was that? A power company. That is a good example of a more regional monopoly, but it goes in another category. So I'll talk about kind of power and utilities in just a minute. How about the Postal Service? So guys, the Postal Service has an exclusive franchise for first-class mail. They're the only ones allowed to sell you the service of first-class mail. Now, you can send packages through UPS and FedEx, but that's not the same as first-class mail. So door-to-door, in those little mailboxes that sit outside your mailbox, we have granted the Postal Service an exclusive franchise, which means nobody can compete. So that is a perfect barrier to entry as well. Would everyone agree? Because government doesn't allow anybody else. All right, a third category that we might talk about might be ownership of resources. Ownership of resources. So we're talking about a situation where the needed resources are controlled and others don't have access. So if you control the needed resources to produce something, that would certainly serve as a barrier to entry. And there are some examples. So one example I found was Alcoa. I think it stands for Aluminum Companies of America, but Alcoa controls a lot of the bauxite. So you need bauxite to produce aluminum. And it turns out that Alcoa controls large amounts of the bauxite supply. So everyone agree, if you control the bauxite supply and you need bauxite to produce aluminum, now it's going to be very difficult for others to enter. So that would be an example of a barrier to entry as well. That's certainly going to keep out competition because they can't access the needed resource in order to produce. Another example is De Beers, diamonds. How many of you have heard of De Beers? De Beers, diamonds? How many of you have seen the commercial that says a diamond is forever? You know that commercial? A diamond is forever? And then it tells you how much you have to spend on a diamond, right? So they say a diamond is forever, and it's all kind of mushy and romantic. And they say, you know, a suggested guideline is 2 months' income. Well, who's paying for those commercials? De Beers. Why do they care? Because De Beers, now it's changed a bit, but they own a lot of diamond mines. So that's clearly the raw material that you need if you want to produce diamonds for retail sale, right? So De Beers supplies diamonds. Now, they don't necessarily run their own jewelry stores, but they're going to be the suppliers of diamonds. I don't know how much they get involved in the cutting of diamonds, but clearly they're going to control a lot of the distribution because they control the mines. So those are some examples, ownership of resources. A fourth category rather, and somebody brought up the electric utilities, and that's a really good example. But that falls under what we call a natural monopoly. A natural monopoly. So a natural monopoly is going to be a situation where it's actually better to have one firm producing. It's actually better to have just one firm producing. So this would be an example of what we might call a good monopoly. We don't normally think of monopolies as being good, but this might be the case where we think of a monopoly as being good. All right? So let's talk about a natural monopoly, what it looks like, but somebody's already given me a great example of a natural monopoly, and that would be a power plant, some kind of utilities. So it could be other utilities as well. So with a power plant, what makes it a natural monopoly is that we're going to see is often with power plants, bigger is better. In other words, when I say bigger is better, what I'm saying is that one large is better than, let's say, two small. So one large electric utility plant might be more effective at producing at a reasonable cost than, let's say, two smaller electric utility plants. So in this case, one is better than two. And we don't say that very often when it comes to production. Let's look at it graphically. Okay? So graphically, everybody with me? So let's look at the case of the natural monopoly. And let's give it a cost structure that looks like this. So let's say its average total cost is really continuously declining over a pretty large size. Okay? So let's give it a cost structure that looks like that. So let's say that we have one firm. So if we have one firm, then let's say that they produce Q hat units. Okay? So if we have one firm, let's say they're going to produce Q hat units of electricity. So that's going to put them at point A on our graph. So one firm is going to be pretty big. It's going to produce at point A Q hat units. And so we see that our average total cost is right here. Call that 1. But now, let's say that we're confused and we decide we are going to divide up this monopoly, because monopolies are bad, right? So we're going to divide up the monopoly. And instead of allowing the monopoly to exist, we're going to cut it in half. And we're going to make it 2 firms. So we're going to divide up the monopoly. We're going to cut it in half. 2 firms. But do we agree that if we have 2 firms, then each has approximately half the market? So if each of these 2 firms that we've just created from the one monopoly exist, then do we agree that they're each going to produce 1/2 Q star? Everyone agree? Or Q hat, rather. Everyone agree with that? They're going to produce 1/2. 1/2 of what was being produced by the monopolist. So that's going to be right about here. 1/2 of Q hat, which puts them on point B of our average total cost curve. And that puts us at ATC2. So what have we just realized? We've taken the monopolist, who was big, we cut him in half because we want 2 firms to kind of compete with each other. And what have we just done to average total cost? Yeah, we've just made average total cost go up. And does everyone agree that's a bad thing for you and me, right? If we're consumers of electricity, we do not benefit at all from dividing the monopolist into 2 and having 2 smaller electric utility plants. Everyone agree with that? So does everyone agree in this example, bigger is better? We'd rather allow the monopolist to produce Q hat, and in that case, we are going to have the lowest possible electric utility costs. So this would be a natural monopoly, an example where monopolies are good. So does everyone agree that the fact that it's a natural monopoly is going to serve as a barrier to entry, right? If one big firm can produce a Q hat and you're going to be smaller than that, do you want to enter this market? No. So what we've just seen here, this cost structure is what we call economies of scale. Economies of scale. EOS. And economies of scale come from a continuously declining average cost curve. So if you have economies of scale, because you have a continuously declining average cost curve, then what that means is, as you get bigger, average costs actually go down. So if you have economies of scale, then you've got a situation where as you get bigger, our costs go down. And electric utilities works that way. Now, I'm not suggesting that it goes down forever. We don't want to have just one electric utility plant for, the entire country. So we want to be clear that this is true up to a point, right? It could end up increasing average cost at some point, but over a reasonable range of sizes, average cost is declining. Does that make sense to everyone? The idea of a natural monopoly? So another example of a natural monopoly that you're also familiar with, guys, is our local cable company. It is also a natural monopoly. Because think about it. The cable companies need to lay a lot of lines, don't they? I mean, if you're going to be a cable company, you've got to lay a lot of lines. So you need a lot of cable lines, which means there's a lot of fixed costs. So guys, if cable companies have a lot of fixed costs, do you want those fixed costs duplicated by the second firm and then spread out over half the market? Or do you want one firm imposing these fixed costs on themselves and then splitting it over everybody, right? So if we have one cable company, then that's good because we don't duplicate efforts. So we're not going to duplicate this expense. And in addition to not duplicating the expense of having more cable lines that we already have laid because another company's already come through, we can spread them over the entire market. So everybody who wants cable, we're going to spread that cost. So guys, do we normally see more than one cable company? Like in smaller markets like this? Do you have a choice? How many of you have cable in your apartments? Some of you, upper level students who don't live on campus, you've got cable. Did you have a choice in Farmville? No, maybe in a really large market. They kind of segment themselves. But in a market like this, do we want a second cable company coming in and laying the lines? And then instead of having 10,000 customers, they only have 5,000 customers. What would happen to cable costs if we had a second cable company come into Farmville? Does everyone agree cable costs would actually go up? And they're already high, am I right? They're already high. So we don't want that. So natural monopolies, when monopolies are good. All right. So quickly to back up, we've been talking about barriers to entry. We've got legal barriers. We've got exclusive franchises. We've got control over resources. We've got natural monopolies. So those are some examples of the kinds of barriers to entry you would see that would create monopolies. All right. So now let's move on and talk about what this graph might look like. So if we were going to graph a monopolist, we've already said we only need one graph. Since the firm is the market and the market is the firm, we only need one graph, right? And so here, we're going to impose a demand curve, but our demand curve is going to be downward sloping, but maybe a bit steeper than it would be otherwise. So we see a downward sloping demand curve. So let's talk about that. So we see downward sloping demand, and the implication of a downward sloping demand curve is that if you want to sell more, what do you have to do? What does this demand curve being downward sloping tell us? If I want to sell more, what do I have to do? What do I have to do? What do I have to do to my price? Lower my price. So if I want to sell more, I must lower price. So if I want to sell more, I must lower price. Now, let's talk about price for a second. Am I a price taker? Am I a price taker? No. How would I describe their pricing behavior? They're a what? Price setter. Good. So the firm is going to be a price setter, right? And it would make no sense to say price taker, right? Because who would they take the price from? Themselves, right? Exactly. The market. But they are the market, right? Everyone agree? So let's remind ourselves. So I would urge you to, as we go through monopoly, let's keep kind of a running comparison to perfect competition. So let's look at a comparison with perfect competition. Kind of do it somewhere on the side so you don't get your notes confused. All right, so what's one thing that we can say? Do they have a downward sloping demand curve? Perfect competition? Downward sloping demand curve? No, what was their demand curve like? Ah, so remember they had horizontal demand. And were they a price setter? No, they were a price taker. Good. They were a price taker. Whose price did they take? The market price. Good. So they adopt the market price. All right. Excellent. So back to the monopoly. So the monopoly has a downward sloping demand curve. If they want to sell more, they have to lower their price. But the firm is a price setter. But do you think this demand curve is overly elastic, or would you expect it to be more inelastic? Would you? Yeah. So the demand curve is going to be relatively more inelastic. All right. So I maybe could have even drawn it a little steeper, but we do want it to be downward sloping. So we want it to not be too elastic looking, right? But we want it to be downward sloping. All right. Excellent. Now, does this mean, guys, if I'm a monopolist, can I set whatever price I want? Can I just set cable at $300? I mean, I'm the only game in town. Can I set my cable price? You want cable? $300. Can I do that? Is that a good strategy for me? I mean, I can do it. Is that a good strategy? Why not? Yeah, we're going to lose a whole lot of business, right? So let's get some notes, right? So can a cable company charge $300? And when I ask that question, I don't mean can they. Of course they can. I mean, can they successfully? So at $300, what do you think is going to happen? They're going to lose a lot of business. People are just going to go without. Of course, there are now some substitutes. What might be a substitute for cable? Yeah, Netflix and Sling, Hulu, Amazon. There's lots of online ways to see things, and maybe Dish Network. What was that? Intel. What was that? Oh, an antenna. I have an antenna. I actually have one of those at my lake house. I was like, what is this thing? But my husband has found a way to get some signal. All right, so guys, do we agree that cable companies could charge $300, but I mean, could they do it successfully? And the answer is no. They're going to lose a lot of business, right? So it might still be better, most likely, to charge whatever they charge, let's say $125, if you have a lot of channels, and have more customers. So just because you're a monopoly, the point I'm making is just because you're a monopoly doesn't mean you can just set some crazy price, right? You still want to maximize profits, right? Let's make a note of that. We still want to maximize our profits. And if we still want to maximize our profits, then we need to find the price and quantity that lets us do this. And $300 is probably not the profit maximizing price for cable. They're going to lose too many customers. You with me? So just because you're a monopoly doesn't mean you're just going to have some crazy, insane price. But it could be higher than otherwise. All right, everybody with me? Okay. So let's take a look then. Let's go back and draw our monopoly graph. And let's say that, so you should probably draw this on a clean graph so we can take some additional notes. Let's say that we're charging a price of $142. And at a price of $142, that puts us at point A. And let's say at 142, we can sell 3 units. It could be 3 an hour. It doesn't really matter. Just keep the math simple. But I can also think about lowering my price. So what's the total revenue right here, guys? Somebody get out a calculator. What's your total revenue if you use this price and quantity combination? Anyone calculating it? No? Not a one? All right. Somebody give me a revenue here. 426. All right. 426. Now, as we just said, if I want to sell more, I have to lower my price. So let's lower our price to 132, which puts us at point B. And let's say that that is 4 units sold. And somebody calculate my total revenue at point B. 528? All right, 528. So we have gained how much? My gain is what? Yeah, $102. So I've lowered my price. I've sold 1 more unit. Do we agree, guys? I've lost this revenue right here. I've lost that revenue in that green box right there. Everyone agree with that? Because I'm not getting $142. I'm getting $10 less, right? For the 3 units that I was selling. So, can we calculate that loss? How much is that box equal to? How much is that box equal to, guys? The area of that box. The box is $10. The vertical distance is 10. What's the horizontal distance? 3. So what do I get when I multiply height times length? 30, right? So we have a loss of $30 because of the lower price. Everyone agree with that? Right? $10 drop in price multiplied by the 3 units. But I'm gaining, we'll keep it in green, I'm gaining this box right here. So this is going to be a gain. Can you tell me the area of that box right there in green? Height of 132 and a length of what? 1, right? So a gain of 132. Everyone with me? So where did this gain of $102 come from? Well, we had a gain of 132, but a loss of 30, which is 102, right? So that's how much our revenue went up, $102. So guys, we have a special name for this, and the name for this is marginal revenue. Marginal revenue. Marginal revenue, if we put it into words, is the additional revenue earned when we sell another unit. The additional revenue earned when we produce and sell another unit. So in this example, it was 102. In equation form, marginal revenue is the change in total revenue given a change in quantity. The change in total revenue that comes from a change in quantity. So we're basically asking, how much does total revenue change when we change quantity? And does everyone agree, for the example we just did, when we went from 3 to 4, total revenue changed by 102 when we changed from 3 to 4, 1 unit. Okay? Easy stuff. So I can lower my price and make more revenues. I can lower my price and make more revenues. That's important to understand about a downward sloping demand. Now that may not always be true. I can't continuously lower it and lower it and lower it and lower it and always make more revenue. But there's a region over which I can lower my price and increase my revenues. Okay? So let's take a look at some more data. Okay, so let's give ourselves a little room to draw a chart. So you're going to need to be able to put together a fairly good sized chart. And I'm going to give you quantity and price, but we're going to add on a couple columns. So make sure you have enough room. So we have 0 and 172. And if you like it reverse P and Q, that's fine too. It doesn't really matter. 162, we have 1 unit. We're selling 2 units when price is 152. 3 units when price is 142. 4 when price is 132. 5 when price is 122. 6 when price is 112. 7 when price is 102. 8 when price is 92. 9 when price is 82. 10 when price is 72. And 11 when price is 62. All right. So I've given you a demand curve, right? Everyone agree? P and Q map in together. This is a demand curve. So the first thing, you're going to need your calculator. So everyone get out a calculator. We're going to need to find total revenue. So get out your calculators, please. And if not, you can probably do a lot of this in your head. Calculate total revenue, right? And total revenue, we remember, is P times Q. That's an equation you need to know. So everyone take a moment and calculate total revenue. I want to see everybody working. So take a moment, calculate total revenue, everybody. All right, take a look. Make sure I've not made any mistakes. Make sure yours look like mine. Everything look okay? All right, so we have found total revenue. Now, from this, we're going to find marginal revenue. Marginal revenue. And remember, marginal revenue is the change in total revenue given a change in Q. We want to remember that it's only defined, just like everything marginal, only defined when Q is changing. So, what do I put at quantity 0? Not 0, mathematically undefined. Remember, I just said it's not defined when Q is not changing. It's only defined when Q is changing, right? So it's not 0, it's mathematically undefined. In other words, it doesn't exist. The idea doesn't exist until we go from 0 to 1. So I change quantity from 0 to 1, and my revenue changes from 0 to 162. Everyone agree that marginal revenue for the first unit is 162. Everyone with me? Now I go from 1 to 2. I've changed again by just 1. And does everyone agree that revenues is changed by 142? So that gives me marginal revenue of 142. Let's do one more. When we go from 2 to 3, we change output by 1. Total revenue has changed by 122. So I want you to take a moment and calculate the rest of your marginal revenues. I want to see everybody working. So even if you don't have a calculator, guys, this you can do in your head. So I want everyone working. All right, check your work up to as far as I've gotten right here. Everyone have the same answers? All right, now let's go from 9 to 10, which we agree is a change of 1. What's happened to total revenue? Total revenue's actually gone down. So what does that tell me about my marginal revenue? The change in total revenue is negative 18, right? Everyone agree? So marginal revenue has gone negative. When I go from 10 to 11, we see that total revenue falls again. It goes down by $38. So marginal revenue becomes negative. So we want to point that out, right? We want to make sure we see that marginal revenue can actually become negative because total revenues are falling. So now we can graph. Let's draw a graph of this. So we know we have a downward sloping demand curve. And if I draw in my marginal revenue, And you want to draw it so that this area equals that area. So it kind of cuts the area in half, and it's got double the slope. So my marginal revenue curve looks like this. And we see that marginal revenue actually becomes negative. And it becomes negative because as we decrease our price to sell more, so it becomes negative because we're decreasing our price in order to sell more. But guys, is decreasing your price to sell more, does that always work? Does it always generate more revenues? What did we learn in our elasticity unit, right? Sometimes we lower our price and people go, eh. We want people to go lower the price and go, wow, a sale. But if that doesn't happen, we've just lost revenue, right? So marginal revenue is becoming negative because total revenue is falling. Total revenue is falling. All right? Total revenue is falling. So now we can determine output. So in our last minute, let's now illustrate, because we already understand this, how does the firm set its output? All right. So setting output. So setting output, let's put in our demand curve and our marginal revenue curve like that. Now we're going to put in our marginal cost curve. And do we agree, guys, that marginal revenue is the marginal benefit of producing and selling another unit? So instead of marginal benefit versus marginal cost, our rule for profit maximization is marginal revenue versus marginal cost. Everybody with me? So if marginal revenue is greater or equal to marginal cost, it's rational to produce another unit. So our shortcut rule puts us right here. So the shortcut, marginal revenue equals marginal cost, just like marginal benefit equals marginal cost in perfect competition. It's the same thing, right? Everybody with me? The only thing we need to remember, though, where do I go to get my price, everybody? Where do we go to get our price? Price comes from where? The demand curve, right? So we have to go up to the demand curve. So let's make a note of that. Price comes from demand. All right, we'll add on to this next class period, guys. So please make sure you read announcements and you know what is going to be due.